Hey guys, welcome to this set of videos. What we're going to do here in this set of videos and this section of notes is, now that we've already again sort of reminded ourselves about what a dilation is, and in fact even learned a few new things about a dilation, we're actually going to now do some dilations. But not just dilations, we're actually going to bring back some of that stuff that we had also talked about from way back in chapter 1, like a translation, a reflection, and even rotations. So let's go ahead and jump right into this. What we're going to be doing is talking here in this section about what is known as similarity transformations. So how can similarity transformations be used to show that figures are similar? Well, first we will need to talk about what are similar figures, and we'll get to that in just a second. Students will identify similarity transformations and then show that two figures are similar. But in order for you to be able to do that, right, you need to know what are similar figures. So, here we go. Once again, let me remind you what a dilation does. A dilation is going to change the size of a figure without changing its shape. Really, really important. Dilation will change the size of a figure without changing its shape. Now we get to this idea of similarity. What that means is the image is similar to the pre-image, but not congruent. So here's the idea with similarity. Two figures are similar if they have the same shape. Now, those figures are congruent if they have the same shape and size, but they're similar if they have the same shape, and that is actually important enough that we're going to write that down. So, let me just write here where I've got a little bit of space. Where do I have a little bit of space? Probably right there is going to work. So, remember that congruent is going to be same size and shape. Equal size, equal shape. You have two figures that are both the same size and shape. What we have now just seen is that similar figures are going to be the same shape, which we already talked about. We talked about the fact in the last set of videos that a dilation maintains the same shape. If you start with a triangle, you're going to end with a triangle. You start with a rhombus, you're going to end with a rhombus. It doesn't change the shape, but a dilation will change the size. So there's a big difference here between being congruent figures and being similar figures. All right, so congruent figures, same size, same shape. And what that means is shape, the angle measures don't change, and the lengths of the sides do not change. But in a similar figure, the angle measures do not change. It'll be the same shape. The angle measures won't change, but it'll be a different size. The lengths of the sides, corresponding sides, will all change by the same ratio. All right, so that's what similar is. So here we go. Similarity transformation. Real important here. Similarity transformation is a transformation in which the image has the same shape as its pre-image. So, if you start with a triangle and you end with a triangle, you just performed a similarity transformation. It's a similarity transformation. So, similar figures. The only way that you can say figures are similar, right? That's why this is an if and only if. So, figures are similar if and only if one figure can be mapped to the other figure through similarity transformations. Now, let's talk about what transformations are similar. And it's actually a really pretty simple question. You don't have to think about it too hard. Think back to the transformations we did back in chapter 1 and now our addition of dilations. So you have reflections, translations, rotations, and dilations. Do any of those transformations change the shape of the figure? No, None of them. They all maintain every single one of these transformations. If you start with a triangle, you finish with the triangle. If you start with a rhombus, you finish with a rhombus. None of them change the angle measure. None of them change the measure of angles. So, all of them are similar. I ran out of space. Similar transformations. Right, all of them are similar transformations. Go ahead, circle all of them. In fact, I should have put E, all of the above, right? All of them. All of them are similar transformations. Why? None of them change the shape. None of them will change the measure of the angles. So they're all going to be similarity transformations. Now, are all of them congruent transformations? That changes the question, right? Congruency means that it's the same shape and size. And we know that reflections, translations, and rotations are congruence transformations, but a dilation is not. A dilation will change the size, which actually is me leading you into the next question. So, here we go. What is the difference between reflection, translation, rotation, and a dilation? If they're all similarity transformations, then what is the difference? Well, reflections, translations, and rotations, the first three, also preserve the first also preserves size, but a dilation does not. So that's the difference. Well, yes, all of them are similarity transformations. All of them are similar. You keep the same shape. They don't all preserve size, right? Dilation will change the size, make it bigger or smaller. Okay, so then what can you conclude about figures that are congruent, and what can you conclude about figures that are similar? Well, remember here kind of an important distinction then. So reflections, rotations, and translations. Reflections, translations, and rotations are rigid motions. Oh. Yeah, rigid motions. So, reflections, rotations, and translations are rigid motions which maintain congruence, the same size and same shape. But a dilation are rigid motions, so they are both, now let me put this, both similarity transformations and congruency transformations. That's sort of rigid means both, maintain size and shape. So rigid transformations, both congruence and similarity. Right? So both congruency and similarity. In fact, congruence implies similarity. Right? When we say two figures are congruent, we're implying that the figures are similar, right? Because congruence means that they're the same shape. They're also the same size, but it means they're the same shape, which is what similarity means. Two figures have the same shape. So if you're going to say that figures are congruent, are congruent, you are, without saying it, you're telling me the figures are similar. But a dilation is just a similarity transformation. There is no congruence here. It does not mean that the objects also are the same size. It just simply means that they're the same shape. So dilation is similarity only. So when I say we're performing a dilation and it's a similarity transformation, you hear similarity and you think, okay, I know they're the same shape. They're not going to be the same size. They're going to be different sizes, either bigger or smaller. Similarity only tells you that they'll have the same shape, as opposed to congruence or rigid motions, which implies same shape, same size. So what we'll do on the next page of the notes is we'll take a look at a couple of example problems where we're actually going to do these similarity transformations, and I'll meet you guys there.